Okay, so this question says, 3 pairs of sisters stand in a line in a random order. What is the probability that everybody in the line is adjacent to her sister? And we need to express our answer as a common fraction. So if we're looking for probability that everybody in the line is adjacent to her sister, well, this can be just represented as the ways for everybody to be adjacent. So the amount of ways there are for each sister to be adjacent over all the ways you can rearrange these sisters. So all ways to rearrange. Or I guess just organize that line. So that's what we're looking for in our probability. So how many ways are there total for these 3 pairs of sisters to stand in a line in random order? Well, 3 pairs of sisters is 6 sisters. So if we have a line where there's 6 slots, well, there's 6 options to decide which girl goes in the first slot. Now that one person is already in that slot, there's 5 options to decide who goes here, 4 options to decide who goes there, 3 for here, 2, 1. And to find the total number of ways we can rearrange, all we do is actually multiply these options all together, because for each person who's going to be in this slot, for each of those 6 people, there's going to be 5 who can be in that next spot, 4 who can be in that next spot. So the total ways to stand in a line is 6 times 5 times 4 times 3 times 2 times 1, or you might recognize that as 6 factorial. Alright, so now we have to find the number of ways for each sister to stand adjacent, to each other. So let's now think about this. We have our 6 girls, and we want all of them to be paired up correctly, right? So this is our 1 pair of sisters, our other pair of sisters, and our 3rd pair of sisters. So if we want all of them to stand adjacent to each other, well, now let's actually not think of it in terms of the circles, the individual people. Let's think of it in terms of the sister pairs. So how many ways can we arrange these sister pairs? They kind of look like Legos. Arrange these sister pairs around. Well, there's 3 of them. So similar to how when we were trying to find the amount of ways to rearrange those 6 people, it was 6 factorial. It's the same thing here, where there's 3 pairs and we're trying to find the amount of ways to rearrange them. And in this case, it would be 3 factorial. Or you can think of it if you have 3 slots, there's 3 choices for that first one times 2 choices for that second one, and 1 choice to decide what goes in that last one. So that's just 3 factorial. So is our final answer 3 factorial over 6 factorial? No, there's actually one more thing we have to consider. So we might have these 3 pairs of sisters like this. But if this is sister A and sister B, well, we could also have it like sister B and sister A. So for each pair of sisters, there's actually 2 different ways to rearrange the order of the sisters. We could have sister A and then sister B, or sister B and sister A. So there's 2 ways to rearrange the order of each sister, which means for however many ways we got that we could rearrange the pairs, well, there's actually 2 times 2 times 2 amount of ways that we can have each sister adjacent to each other, because, well, now we have to look inside of the pairs and figure out, well, we can flip around each of these sisters. So there's 2 cases for each pair. So this is going to be 3 factorial times 2 to the 3rd, or 8. So this will just be 6 times 5 times 4 times 3 times 2 times 1 is 3 factorial. So this will cancel out on the top and the bottom, leaving us with 8 up here. We can cancel out the 8 and the 4, leaving us with 2, and then 3. So this ends up being 1 over 15.